Today we shall be looking at electronic configuration of atoms. Electronic configuration of atoms. Electronic there is coming from the word electrons, and configuration simply means arrangement. So we are going to look at how electrons are arranged in the shells of atoms of different elements. Okay, so before we move forward, we are going to look at the laws that govern the filling of electrons in the shells of elements. Okay. All right, so the first law there is Pauli exclusion principle. Pauli exclusions principle. This law simply states that that there is no two electrons in an atom that can behave in the same way for all the four quantum numbers. Okay, just to mention, we have four quantum numbers, and they are the principal quantum number, azimuthal quantum number, spin, and magnetic quantum number. So this Pauli exclusion principle is saying that for all the electrons in a given atom, that there is no two that will behave in the same way for all the four quantum numbers. So that means that each electron has its own behavior or has its own arrangement or characteristics. Then the second one there is Hund's rule. Hund's rule. Okay, so Hund's rule is talking about degenerate orbitals. Degenerate orbitals simply means orbitals that have equal energy. Orbitals that have equal energy. Okay, so remember we said that orbital is a region in an atom where there is possibility of finding electrons. Now, different orbitals, as they orbit or as they arrange around the nucleus of an atom, they do not bear the same energy. But there are some orbitals that have suborbitals inside of them. So, for example, we have p orbital. It has three different suborbitals. So it has px, py, and pz. Then the same thing with f and d orbital. So when you are writing or putting an electron into these degenerate orbitals, orbitals of equal energy, you have to take into cognizance this rule. So you must fill them singly first. That means you give each of those degenerate orbitals one electrons each. Then if you still have electrons left, then you can start pairing them. So that's what this law is saying. Okay, so it says that in filling electrons in degenerate orbitals, that they are filled singly first before pairing. So you fill them singly first, you put one electron in each of those degenerate orbitals before you start pairing them up. Okay, then the last law or rule there is Aufbau's principle. Aufbau's principle. Alright, so Aufbau's principle says that for you to fill electrons into orbitals that have different energies, that you should fill those electrons into the lower energy orbitals first before those of higher energy. This is very applicable in our families when we want to show love to children. We usually put into consideration, their positions or their birth position. For example, if you share gift, for example, for you to give gifts to them, we usually consider that the young guest should be given first, okay, before you give to the oldest, because we believe that the oldest can always withstand hunger. And then also when you come to secondary school, we have junior secondary school and we have higher senior secondary school. At the entrance, when you come into secondary school, it is always advisable that you begin from JSS1, because JSS1 is the lowest class in terms of the content, or the complexity of the questions that they could be given in examination. So that is also how it is for orbitals. Orbitals of lower energy should be given electrons first before those of higher energy. Now, this is the arrangement. All the orbitals have been arranged this way. So this is how you will know the one that have lower energy than other ones. So we shall be making use of this diagram as we go ahead to write the electronic configuration. Then, for us to write the electronic configuration of atoms, we have two methods that we can use. Two methods. So the first one there is electron dot diagram. And then the second one is orbital diagram. Electron dot diagram and orbital diagram. So we shall be making use of these two. First of all, we are going to look at the electron dot diagram. So to write, we are given this question to write the electron dot diagram of these atoms. We have chlorine and carbon. So we begin with chlorine. So chlorine has atomic number of 17, and remember that the number of atomic number or proton number is the same thing as the number of electrons too. So the atomic number is same thing as the number of electrons. So invariably it is telling us that the number of electrons that we have to share is also 17. So we start. Remember, the first shell can take maximum of 2. So we have given it to 1, 2. The second shell will take 3, 4, 5, 6, 7, 8, 9, 10. So far we've shared 10 electrons, 10 out of 17. So we have 7 left. So we'll add another shell. Remember, we have given 10 already. So 10 will continue to count. 11, 12, 13, 14, 15, 16, 17. So that is the whole of the electrons given us here. So here we have, according to the shells, we have 2 for the first shell, 8 for the second, and then 7 for the last one. So this is the electron dot diagram for chlorine atom. Then let us draw that of carbon. Carbon has number of electrons 6. So the first shell we give it 2. Second shell we continue to count 3, 4, 5, 6. Remember, we have 6 here. So for this we have 2:4. So this is how to write the electron dot diagram of atoms. Apart from using the dots, you can also use X, that is like asterisk, in place of this dot. Is still acceptable. Alright, so we move over to the orbital diagram. The question says we should draw the orbital diagram for the following atoms. We have beryllium, nitrogen, and sulfur. Beryllium, nitrogen, and sulfur. Remember, always bear in mind that you must arrange these orbitals from the lowest energy up to the higher energy, and that is how you are going to be filling electrons into them. Okay, so preferably if we choose to use this method, let me use this first method for this first one. The lowest energy here is 1s, so if I write 1s, s can take maximum of 2 electrons, so this is 1s 2. So remember we have 4 electrons to write or to draw. So 4 minus 2, we are left with 2. So after 1s, the next one there is 2s, and s still takes maximum of 2. So this is the orbital diagram for beryllium. Then invariably we can also draw it like this. You can decide to put it in boxes, so that this is 1s. So let me write it. This is 1s. Remember this, the reason why I drew it this way is because 1s is lower in energy than 2s. So I draw the 1s at the base, then I move a little up to draw the 2s, showing their gradation in energy. So for this one, I'll now decide to write it this way. Remember, to fill electrons, Pauli exclusion principle have told us that we must arrange it in opposite spin this way, because there is no 2 electrons that will have the same behavior or spin for all the quantum numbers. So when you come to here, this second one, you also have it like this. So it's either you write it this way or you write it this way. Either way, you are correct. So next, let us draw for nitrogen. So for nitrogen, we have so this is 1s. Let me clean this so that we can see. This is 1s, 2s, 2p. Alright, now for 1s, we have 7 electrons here to write. So give 2 to 1s, give 2 again to 2s. So we've removed 4 out of 7. So we are left with 3. So when you come to this 2p is an example of degenerate orbitals, meaning they have equal energy. You can see that all of them are standing on the same flat level, meaning that they have the same energy, both this box and this one. That is px, py, and pz. So when you come here, you fill it singly first. You give them one electron first before you start pairing them. So since we have 3 electrons left, we'll go ahead to give them 1, give this one 1, and give this one 1. So this way, we've been able to represent the electronic structure or diagram for nitrogen. Then we move over to sulfur. Sulfur, we do the same thing. We have this. Remember, this is the first one, which is 1s, 2s, 2p. So I've written for this, and then I'm here now. I've written for this. So the next one is 3s. I'll move up a little and draw for 3s. Okay, let us start filling. So we have 16 electrons to share. So give this 2, give this one 2 electrons. We've removed 4. So when you come to p, you give them singly first before you start pairing it. We are going to pair because we have plenty of electrons left. We've already filled 1, 2, 3, 4, 5, 6, 7. We've removed 7 out of the 16. So right now, we'll go ahead to start pairing. So we'll pair here, and pair here. So far we've removed 10. This is 2, 2, and 6, 10. So we are left with 16. So we'll come here, we'll write here, this is 12, so remaining 4. That means we're going to add another orbital. So remember, I've written for this 2p and 3s. Now the next one in terms of energy is 3p. So this is 3p. Now remember, we are having 4 electrons left. 4. So I'll write for this 1, 2, 3. And then I'll pair this one 4. So this is 2, 2, 6, 10. Then this is 1, 2, 3, 4, 5, 6, 16. So this is how to draw the orbital diagram for atoms of elements. So feel free to explore other examples, and let us also look for an atom that has a higher electron and see how to let's look at scandium. Scandium has atomic number or number of electrons as 21. So to draw for this, we have this. S. Okay. 3p. After 3p, we have 4s. 4s. Okay. So let us see. We have 21. We count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've written 10 so far. Let me move closer so that we can see it clearly. So we filled 10 so far. So remember 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we are left with 1 electron more. So let's make reference to this orbital here. So remember, I've filled for 1s, 2s, 2p, 3s, 3p, 4s. So the next one now is 3d. That's the next 3d in energy. So I'll quickly, let me clean here so that's 3d. Remember, d has 5 sub orbitals. So we'll move up and draw for it 1, 2, 3, 4. So D has 5 kinds. So remember, we only have 1 electron, so we'll just write it here. So this is 2, 2, 6, 10, 12, 18, 20, 21. So that is how to do this. All right, thank you very much. I'll see you in the next class.